Okay, recording has started. Share. Oh, can everybody see my screen?
Yes, please.
Okay, so I'm going to talk to you today about the morphology and taxonomy of African Malpighiaceae. Rafael Felipe de Almeida. I'm a research assistant here at Kew Gardens. And I've been working for the past 10 years with Malpighiaceae. And it's very interesting because this family is not notoriously known to be very diverse in Africa, in the African continent and Madagascar. But for some groups, it actually is very diverse and nobody quite studies it properly. So I hope that with today's presentation, I can encourage people to start working with taxonomy of Malpighiaceae in Africa, because it's a beautiful, beautiful group, and there's a lot to be done in Africa, and hopefully, I hope you enjoy. So, are you gonna change? Yeah. So I'm going to start talking about the taxonomy first. So Malpighiaceae within, could anybody let this person in? Sorry, I don't think anyone else can do that. Yeah, you got it? Okay, great. Sorry. So Malpighiaceae within angiosperms is placed in the order Malpighiales. So it's a very large order with more than 40 families of flowering plants. This order is very economically important for various groups. So we have very important crops like the cassava, the passion fruit, the, wow, sorry, it's not properly showing. I don't want this to be shown. Okay. So with the cassava crops, the passion flower fruit, very other important plants as ornamentals as the violets, the salix genus for giving us the salicylic acid, a very important medicine used into today. Of course, the cocaine is not important, but it is important in some aspects. And the St. John's wort, which is the family Hypericaceae. So within this order, Malpighiaceae is placed here in this Malpighioid clade. So there's been a lot of talks over the several years, like the past 10 years, about the relationships between those families within Malpighiales. We have not reached a consensus yet, but this subdivision into four major clades seems to be what is really most probably near the truth about Malpighiales. So Malpighiaceae is sister to a tiny little family of herbs called aquatic herbs, actually called Elatenaceae. So it's really intriguing to me to compare morphologically a huge tree like this one, that is a very common tree in the savannas of South America, with this tiny little aquatic plant that occurs worldwide, because they do not seem to be morphologically related, but after several molecular phylogenetic studies, we're 100% sure that they are sister groups, even though morphologically they don't make much sense. So the distribution and diversity of Malpighiaceae nowadays, the family is currently divided into 70 genera and around 1,300 species. So the neotropical region here in the American continent is the center of diversity of this family, with 58 genera and about 1,000 species occurring only in this continent, and 15% of the remaining diversity of the family occurs in the Paleotropics, which comprise the tropics of Africa, Asia, and Madagascar, and a little bit of Australia. So when we see like this, these numbers, we might actually think that Malpighiaceae is not that diverse in Africa. You don't have anything like relevant or beautiful or interesting to study, but it's far from the truth. So I'm going to start talking about the morphological characterization of this family. So the first morphological character that we can easily spot to identify this family is their Malpighiaceous hairs. So what is it? It's one cellular, two branched hairs with or without a foot. So this entire thing that you can see macroscopically and touch it, it's comprised of a single cell, and it always has this shape, like two branches and a foot, or the foot is very reduced and you can only see these two branches. So this is called Malpighiaceous hairs because for the first time when it was described in the literature, it was described for this family, but we know nowadays that it's not exclusive of Malpighiaceae, so it is found in a bunch of different families within flowering plants, even outside the dicotyledons. But for Malpighiaceae specifically, Malpighiaceous hairs with one cellular hairs is exclusive of Malpighiaceae. So you can find Malpighiaceous hairs with more than one cell in different families of flowering plants, but only one cellular two branch hairs are found in Malpighiaceae. Another morphological characteristic that is really helpful in identifying this family is their sepals. They always bear eliophores. What are eliophores? They are oil-secreting glands, and that's a little bit tricky when we're talking about neotropical and paleotropical Malpighiaceae. You're going to understand this issue a little bit more in depth uh, in a few slides. But for now, you just need to know that only neotropical species of Malpighiaceae have those oil-secreting glands on their sepals. So African, Asian, and um, plants from the Oceania region of Malpighiaceae, they don't have oil-secreting glands. They have different types of morphologies, and I'm going to explain to you in a few moments. And another very useful morphological character to identify Malpighiaceae in any part of the world is that all their petals are clawed. What do I mean by that? They are narrowed at the base, so they always show a claw because it's a narrow region of the base of the petal. So even in the African and Asian Malpighiaceae, we have this type of morphology. So it's also really useful for us to identify this family. So another very interesting thing about the Malpighiaceae is that they have a very striking floral conservatism. So what do I mean by that? I mean that most of all, neotropic genera of Malpighiaceae, they have kind of the same floral morphology. What do I mean by that? For example, if you see here this comparison between neotropic plants and paleotropic plants of Malpighiaceae, you can notice that the neotropical species, they show more zygomorphic flowers, and the paleotropics show somewhat zygomorphic flowers, but mostly actinomorphic flowers with a very different flower morphology. So that's very, very interesting, and it governs most of the taxonomy and the morphology and evolution of this plant. And it's all related to their pollinators. So in Neotropical Malpighiaceae, all species, they are pollinated by oil collecting bees from different genera and field groups within bees. And the interesting thing is that only in the neotropical region of the world we can find these oil collecting bees from this specific groups and genera. So that's why they have this specific coevolution with Malpighiaceae in the neotropical region of the world. And in the paleotropic region of the world, we don't have those lineages of oil collecting bees. We do have some lineages of oil collecting bees, but from different genera and from different groups that do not have any kind of correlation or mutualisms with Malpighiaceae species. So that's why early in the taxonomic literature, people started thinking that that would be the probable explanation why paleotropical Malpighiaceae do not show conspicuous flower morphology like the other ones from the neotropics. And then about 10 years ago, actually 13, people started studying that and trying to figure out what's happening and what's the driving force behind the morphological diversity in Malpighiaceae from different continents. So this study from 2010 studied like the gene mechanisms and development of symmetry expression within Malpighiaceae flowers, and they found out that there's two variants of the same gene, SIC-A and SIC-B, that establishes the zygomorphy in Malpighiaceae, and they also noted that all the neotropical species that they analyzed of Malpighiaceae showed both of those variants of this gene, but here in the old world lineages that they analyzed, they only showed one, SIC-A, and no SIC-B. So they hypothesized that probably it was due to active selection of those oil collecting bees. So since when those lineages of Malpighiaceae reached the African continent at some point in the geological past, they found out a different environment without oil collecting bees. So they had to adapt so they could thrive and prosper in that region. And some things changed. And one of those things was their flower morphology due to the absence of the oil collecting bees. So that's the main reason why most of African genera of Malpighiaceae that I'm going to show you later in this presentation has a unique flower morphology that is so different from the neotropical species. And why I'm talking to you about that, because you need to understand where I'm coming from, and also that few genera of neotropical Malpighiaceae, they reach Africa, and you have those two different flower morphologies. So you need to understand that so you can be able to differentiate and know better their morphology and taxonomy. So just for us to finish that line of thought, one thing that's very interesting about Malpighiaceae is that the center of origin of this family is considered to be South America. And we know nowadays that we had 9 different dispersal events from South America to Africa and to Asia in in the geological past time. So the first one here, second, third, and so on. And what is very interesting to know is that even though we have 9 different lineages that just dispersed the from South America to the Paleotropics. Most of these lineages, they end up in Africa or in Madagascar. So that's a very, very interesting pattern, and I'm going to show you more to you in a few moments. So now talking about traditional classifications within the family, we have a lot of them, and the three most important ones are from Jussier, which was the first person to do a monograph of the entire family, is the Jussier son, not the Jussier dad. Jussier dad described the family, but Jussier son did the monograph, the first one in the family. Then we have a study from Franz Niandezu in 1928, and a more recent study is not actually a study, it's a collection of different papers and studies and book chapters that kind of resemble taxonomic classification, but it's not complete, and it was made by William R. Anderson, an American, North American taxonomist. So when we used to work with taxonomy only based on morphological characters in the past, we had this division of the family in two subfamilies, one subfamily with fleshy fruits and the other one with dry fruits. And we had a subdivision of the subfamilies in tribes, also by the type of fruits. So if you have drupes, it's a tribe. If the schizocarps with smooth mericarps, they belong to another tribe. Winged mericarps, another tribe. And uh, specific tribe of specimens with mericarps having setae or bristles instead of wings or being smooth. So, however, nonetheless, when the first molecular phylogenetic studies took place in the past 20 years, more specifically in 2010 by Davis Anderson, they did an entire molecular phylogenetic study sampling all genera of Malpighiaceae, and they found out that actually this entire classification system proposed based on morphology was completely wrong. And instead, the family is currently divided in 10 different groups that they don't have any taxonomic recognition, so they don't have any taxonomic ranks. They are, until this day, known as informal clades. So they recognize these 10 informal clades, and then they mapped the type of fruits according to this grouping that they recovered according to the molecular phylogenetic study. And as you can see here, the evolution of those different types of fruits, like dry fruits, fleshy fruits, or both of them, happened several times throughout the evolution of Malpighiaceae. So this would not be like the most reliable morphological character for one to choose to create a taxonomic classification system for this group. So that's why since then we don't recognize any formal taxonomic classification within Malpighiaceae, because until this day no one has properly explored morphological characters within all of those clades to find morphological characters as synapomorphies or homoplasies that supports each of these informal groups. So anytime that you hear in this presentation the ending oids, when I'm talking about something oids, I'm talking about those informal clades that are currently recognized within Malpighiaceae. Now I'm going to talk a little bit, actually a lot, about morphology of Malpighiaceae. So I'm going to start with habit. So the habits in the family, they vary a lot. So we have a few genera and few specimens that are currently represented by trees, but most of the representatives of this family, they are characterized as shrubs, lianas, or subshrubs. So what's the difference between a shrub and a subshrub? It's only related to the presence of an underground storage system, in this case, a Silopodium, that it's really common in plants from savannic environments, both in Africa and South America. So every time that you see something in a savanna that looks like a small tree or a shrub, you need to dig first in order for you to find some underground storage system, because if you find, you cannot classify it as a shrub, it is a subshrub, okay? And it's really, really common in African Malpighiaceae as well. Subshrubs, lianas, and occasionally shrubs. Uh, Talking a little bit about the trichomes in the family. So as I told you, the trichomes in Malpighiaceae, they are unique because they are one cellular, two branched hairs with or without a foot, called Malpighiaceous hairs, and they might show different morphologies. So they can have straight branches, wave branches, spine-celled wall. How come? So it's really weird, but for several genera in Malpighiaceae, when you get only one of those trichomes and you try to analyze them under a stereo microscope, if the trichome is large enough, you can see little spines in the cell wall of the trichome. And it's really interesting because they really look like spines. And there's a whole ecological function that I'm going to talk to you a little bit later, but it's really weird. And if you touch those kinds of hairs with spine cell walls, you will get itchy hand because it itches a lot. It's the worst. So, and you also have like different types of shapes. So it could be a T-shaped hair with a very reduced foot, a Y-shaped, but one of the branches are smaller than the other, or it's a V shape because the foot is completely missing. And you also can find like a T-shaped hair in Malpighiaceae that is not cylindrical like a normal hair of a plant. It actually is flattened like on the sides, so it looks like a tiny scale. So for some genera of Malpighiaceae, you only find these types of hair, most specifically in their inflorescences. So here are some scanning electron micrographies of those type of hairs, so you can see a little bit in detail of what I'm talking about. So when when you have like a bunch of trichomes together, you call it an endowment. And the general aspect formed by a group of trichomes, it's what drives the terminology of endowmentum in Malpighiaceae. I'm not gonna say that I actually agrees completely with this kind of terminology, but it's the currently terminology that it's in use in the family, and it's very difficult for us to not use it. So every time that you find an endowment that it's has Y or V-shaped hairs, you call it a velutina endowment. Uh, but when you find an endowment comprising only T-shaped hairs, but without any foot, you call it a sericious endowment because they will be so oppressed to the epidermis of the structure that it will resemble like sericious thing. It will be like very, very glossy. But if you have T-shaped hairs with a very pronounced developed foot, you call it a tomentose endowment. So these are the three basic types of endowment that you can find in Malpighiaceae specimens, also from Africa. And you can do variations of that using different kinds of terminologies regarding indumentum that you can find in common morphological glossaries that are used within plant taxonomy, but those three are the basics. Also, you can see here the spike projections on the cell wall that I was mentioning. So it's really weird to think that this entire structure is a single wall, is a single cell actually, and in this wall of this single cell, you have projections that are really, really weird and look like spines, and they attach to the epidermis of anybody that comes in contact to it, and it itches a lot as a result. It doesn't actually releases any kind of chemicals that causes the itching. It's more of a mechanical thing that causes the itching, and it's mainly an ecological oh my gosh, I forgot the word in English, strategy to avoid herbivory or to make herbivores eat less of a specific structure. And you can also have like varicose projections on the cell wall of some trichomes. So instead of being like a proper spine, it is more of a rugi. So now talking about branches, we can have different shapes and different textures in Malpighiaceae. So most Malpighiaceae would have a cylindrical shape of their. A few specific genera or even species might have flattened branches or even squared ones. It's really, really rare, but we do find it. And the texture of those branches also varies greatly. So you can have smooth branches, striate branches, lenticellate branches, and really common that the color of those lenticelles they might change from species within a genus. So in this one called Heteropteris, we can see here the lenticelles they are whitish, but in other species that are probably related to this one, they might be blackish, they might be reddish, and this might not seem at first sight as a very useful morphological character, but in fact it is, and it's really helpful in differentiating closely related species. We also might have branches that are costate, fissured, like deeply fissured, that is completely different from the striate version, which is not that deep, and varicose branches, or different types of textures that are not represented here, but are very, very rare. But the common ones are those six ones. Now, talking about phyllotaxis, most species of Malpighiaceae, they have opposed leaves. But in a few genera, they might be decussate, which opposed, which means opposed, but instead of being opposed in only in one way, it reverses. And a few species and a few Malpighiaceae genera, they might show alternate leaves. And another type that is really, really rare, only a single genus that occurs in South America, I know that to occur this type of phyllotaxis, that is the verticillate one. It's a genus called Pterandra. Regarding the stipples, they are very, very important and useful in the taxonomy. So their position and conation is really useful. So they can be interpescular when they are positioned in the branch within two leaves. They're here. But if they are positioned at the base of the leaf instead of being positioned in the branch itself, they are called epipescular. So there are several genera that you can differentiate from having only one type or the other of sepals, and they can also be free. So they are free most of the times, like you're seeing here in this image. But in few specific genera, this one called Peixotoa, that is very common in the savannas of Brazil, both of those stipules, they are connate, they are fused into a single structure. And this kind of things also happens in some Malpighiaceae genera of Malpighiaceae, which is very, very interesting. The petioles, they vary in size and shape, so they can be sessile, rarely, or most commonly very short, or very, very unusually long, specifically in this genus called Stigmophyllum, which we have one species occurring naturally in West Africa. And the shape of the petioles is also very, very informative. So most of them will be circular. So why do we have like these smiley faces here? They are actually the transversal cut of partial. So you take the partial and you cut here transversely, and you're gonna see the vascular bundles. So the vascular bundles, they are grouped this way in Malpighiaceae, with a large one below and two upper ones, making this smiley face. So it's very, very useful for us to see the shape of the partial this way, because I think it's easier for us to visualize. So this one is circular. Uh, or it could be like plain convex. It means that the upper part of the partial is like flattened, or it can be canaliculate. So you have like a deep fissure in the upper part of the partial that makes like a little channel called canaliculate. So the petioles in Malpighiaceae, they oftenly bear lots of glands. So extrafloral nectaries, or also known as glands, like glands occurring in structures not within the inflorescence flowers or fruits. They might occur in the petioles or on the leaf blade itself of Malpighiaceae, but in the petioles, they can occur at the base, at the middle, at the apex, like you can see here, or as a mixture of this type of positions. So you can find here at the apex, here in the middle, or more closely related to the base of the petiole. And also the position among themselves, it's important. If here it's alternate, but here it's opposite. So depending on the specimen and depending on the genus, we have different patterns, and these are the characters that you should look for when looking at a specimen of Malpighiaceae. Now I'm gonna talk a little bit about the laminas, like the leaf blade shape. So the most useful classification for leaf blade shape in Malpighiaceae is this one from a very old paper published at Taxon in 1962, I think, that that very old morphological glossary called Radford uses in that book. So I just modify it from the original paper. And it's very, very useful because here you can use only the proportions of the leaf blade for you to give a specific name. So I think it's more objective. So it's easier for us to use this way. So later on, I'm going to share this entire presentation with a PDF of a book that I published last year about the morphology of Brazilian Malpighiaceae, which I've based like 80% of this presentation on. and you can take a little closer look into all those patterns. But we do actually find most of those patterns in Malpighiaceae, especially on the lianas, because the lianas are the most diversified ones within the family, and they sometimes might have uh, two different types of leaf morphology on the same genus. So it's crazy, but I'm going to show you a little bit more later. Lamnus base, we have different morphologies from sagittate to rounded to cordate, cuneate, obtuse, truncate, oblique, attenuate. So this would be like my version of a morphological glossary for Malpighiaceae. I'm not saying that we only have these types. These are the most common ones, but it also these images are also based only on the morphology of Brazilian Malpighiaceae, which is the center of diversity of the family. But also, it doesn't mean that in Africa you might not find some morphological variety or character that does not fit into this. The margin is a very useful character also in the leaf blades of Malpighiaceae because in a single genus called Stigmophyllum, again, which by the way is my favorite genus in the family, um, they can show different types of leaves shapes in the same species. So here is the same species, Stigmophyllum catangicula. It's a new species that I described a few years ago, and it's very interesting because in the same specimen, at one side of the specimen, I found entire unlobed leaves, and in the other end of this specimen, it's like a huge liana occurring in dry forests in Brazil. I found a three-lobed leaf, and it was really weird. I couldn't believe what I was seeing, but I was seeing that. So you can find this kind of morphological variation within Malpighiaceae, and especially in the lianas. And since there are several lineages of lianas in Africa, I think that they haven't been properly studied in the past, because the only studies in Africa are those from the flora of East Africa and some regional floras, and they actually just started to explore the taxonomy and morphology of African Malpighiaceae, and I think there's still a lot of room to do a lot of different studies to um, explore more in depth all of those aspects. So the margins of Malpighiaceae can also be crenate, ciliate, also really weird. So the first time that I saw that, I thought that each cilia here was in fact glands, like really long glands. But when I studied more in depth using scanning electron microscopy, I found out they are really hairs, but a really weird hair that is not like that one that I showed you before, the Malpighiaceous hairs, a different type of hair that is really weird, and nobody has ever actually studied more in depth, like ontogenically, with plant anatomy and other techniques for us to figure out what it really is indeed. But anyway, you can also find these weird types of hairs in Stigmophyllum or some closely related genera. Or here the margins could also be dentate. In Africa, most genera, they don't show any kind of different morphologies in the margins except for Stigmophyllum, the crazy one. So watch out for them. The laminas, the margin and the base are also very useful. So we have the usual ones, the morphology. So they could be acuminate, rounded, mucronate, acute, or marginate, cuspidate. But one thing that is really, really important in some groups is the shape of the margin is like not the shape, like the posture. So if the margin is plain, like straight, is the most commonly found one in Malpighiaceae, but there's a lot of species and genera that only show revolute margins. So it's a really, really useful character for us to spot doing field work or analyzing herbarium specimens. And easily distinguishing or finding a group of specific genera that that specimen might belong to, especially in Africa. So laminas here, divination patterns, the most common one is Brachydodromus. In very few genera, we might find the Eucamptodromus one, in which the secondary veins, they don't reach uh, each other. So here in the Brachydodromus one, they reach each other and they form this pattern. And the Actinodromus one, they are only currently found in a stigmophyllon because they have like not entire leaves, margins. They have lobes. So by definition, the lobes make this with the leaf venation, and they are always actinodromous. And the type of reticulation in those laminas in the patterns of lifination, they are also very important. So here in this photograph, you can see that every vein on the abaxial side of the leaf blade, it's raised. So it's very conspicuous and they are raised. When you just put your finger there, you can feel it like really, really raised. And some species, they are known for having those raised veins, but other ones are known for having like impressed veins, those ones that you cannot feel when you touch them. So they are just really immersed within the leaf. So you have different patterns of primary, secondary, tertiary, and quaternary vein in Malpighiaceae, and also the extrafloral nectaries, the glands. So, for example, the most common ones, we can have sessile or pedunculate glands in the leaves of Malpighiaceae, and also the apex of these glands, it can vary from being cupuliform, like a little cupula, or a disc, like this one, discoid, or here as like more or less a cupula slash discoid, but with a very pronounced peduncle. So there are several genera in Malpighiaceae that are very, very rich in glands in different morphologies, different exudates, and different structures of the plant. So please pay attention to them because they are really important in the family and really, really useful in their taxonomy. And the ecological function of this extrafloral nectaries in Malpighiaceae is mostly attracting ants, like they're recruiting foraging ants to patrol those branches with those structures that bears glands. So the plant itself can avoid and be protected from herbivory. So this specific ant in Brazil bites you like very, very gives you a very, very painful bite. So I don't recommend it. And please also take really good care when collecting and doing field work with Malpighiaceae because it's very, very common to find those ants. And I really think that you also have this system in place in the African lineages because they also have a lot of glands. So you might be bitten by angry foraging ants. So now let's talk about a little bit about the inflorescence types. It's taboo in Malpighiaceae because it's a little bit tricky. It seems difficult, but it actually isn't. So what happens with Malpighiaceae? Every single genera and species in this family, they have a compound inflorescence. What do I mean by that? That their inflorescences are not simple. And how do I know that? So a flower, it's comprised by the receptacle, the calyx, here the pedicel, and everything from the pedicel below, it's not part of the flower anymore. It's part of the inflorescence. So here, this structure, this peduncle, these two bracteals, and this bract, they are actually the remnants of a type of inflorescence, a simple inflorescence. So That's why we don't say that Malpighiaceae has simple inflorescence. The inflorescences are always compound. So this entire structure that seems to be a single flower is not actually a single flower. It is a one-flowered cincinus. So it's the first order inflorescence. So you don't need to memorize these difficult names. You just need to know and accept right now so far that every time that you see a single flower in Malpighiaceae, you're not seeing a flower. You're seeing a one-flowered inflorescence. Okay, so there's also a different variation within the morphology of the peduncles here and bracts and bracteoles here. I'm just making sure that you're seeing that here the bracteoles, they are placed in the apex of the peduncle. Here they are placed in the middle, and here they are placed at the base of what seems to be a pedicel. So what happened to the peduncle here? It's gone, like it's completely absent. So you have this kind of variation within a lot of different specimens, species, and genera, more specifically in Malpighiaceae. So here we're gonna talk a little bit about inflorescence architecture. What do I mean by inflorescence architecture? I mean, what are the arrangements that we can find regarding compound inflorescences in Malpighiaceae? So here on the left, you can see a model of inflorescence evolution published in the 80s for Malpighiaceae that the author he hypothesized that, for example, the ancestral Malpighiaceae had tierces of multi-flowered cincini. So each of these branches here, they are one simple inflorescence gathered into another type of inflorescence by this main axis. But throughout evolution, the number of flowers in each of those cincini was reduced, we don't know why, to one. So nowadays we have this common type of inflorescence in Malpighiaceae that if you don't know that Malpighiaceae have compound inflorescences, you're gonna call it raceme, but a raceme is a type of simple inflorescence. So as Malpighiaceae do not have simple inflorescence, we cannot call it a raceme. So we call it a tersus. So it's a tersus of one flowered cincini. You don't need to say like the entire name, you just say a tersus. And if you think evolutionarily, the way of a tersus can become throughout the geological time uh, corymb and then later a umbel, it's just by the reduction of the internode space. So you have the internode region and it's progressively being shrunk until a point in which it is lost completely. And instead of having a tersus of one flowered cincini, you have a corymb. If you still have like tiny internodes, but when you completely loses them, you get an umbel. And not only an umbel, usually umbels in Malpighiaceae, they are composed of four flowered cincini. So instead of having only one flowered cincini, you have four one-flowered cincini. So it is accompanied with a reduction in the number of flowers alongside the reduction of the internodes. And here it's just an example of how messy the compounding inflorescences of Malpighiaceae can be. So here you have an example of a umbel. But remember, this is a number of one flowered cincini, a corymb of one flowered cincini, and a tersus of one flowered cincini. However, in lianescent general and climbing plants, they can usually show very tricky morphologies in their inflorescence architecture. So if you pay attention here, the first order of arrangement here, it's one-flowered cincine arranged in an umbel that are arranged in a second order in a dicasion, which is also arranged in a third order in a tertius. So it's really, really weird, but it's what happens in Malpighiaceae, and that's why you need to pay careful attention to the types of inflorescence architecture that you're seeing in the field or in your specimens, because if you only have this part, you might think it's only, oops, sorry, a umbel, or here only a dicasion, but here you can see the entire picture that is a little bit more complicated. So regarding bracts and bracteals in this one-flowered Cincinnati at Malpighiaceae, we can have different shapes, we can have different postures, and we can have or not the presence of glands. So here, for example, we can have the bracteals covering the entire flower bud and a very reduced pedicel, or here we can have the bracts and bracteals patent, so it's a little bit spreading from the peduncle, or they can also be spreading but with a different shape. So instead of being flat, they are cuculate. So every time that you hear this term cuculate in Malpighiaceae, it means that it's bow shaped. And you can also have here sessile glands or peduncle glands at the margins of bract and bracteals. So we have a great variety of morphologies within these tiny little structures that you need to pay attention to, because sometimes you can differentiate approximately related species only by the shape, the number, or tiny specific morphologies within these structures. Now, talking properly about floral morphology. So, as I told you before, Malpighiaceae is known by their zygomorphic flowers, but this type of morphology is only found in neotropical ones. In the paleotropical ones, the African ones, it's a little bit different, and I'm going to talk to you about that in a few moments. So here we can see let me start with the lateral petals. So the lateral petals, they are in yellow. The posterior petal, it's in orange. So the sepals are those traces here in green. So they have 5 petals and 5 sepals. Okay, the petals are always placed like this, just played like this in neotropical ones. So you have a posterior petal and 4 lateral petals. The sepals is the opposite. You have anterior sepal and 4 lateral sepals. Okay, and each sepal might bear eliophores or any kind of gland. So it's very common for neotropical species of Malpighiaceae to not have the pair of eliophores here in the anterior sepal. Why? We don't know much about that, but that's the pattern that we find studying those plants. Here we have always a ring of 10 stamens that are fused at the base, and each blue uh, thing here is the connective, and the white circles are the pollen sacs, and here in the middle we can find the trilobate genuation, that is compound of 3 carpels that are completely or partially fused at the ovaries, and that's it. Okay. So regarding sepals, we can also have like different morphologies. So here we can have the sepals concealing the sorry, no, I got lost here in my line of thought. Here we have like a sepal with a glandular base, rounded apex, or you can have sepals that are one or two glandular. Here in this specific image is a Iptage bengalensis, is a plant from Asia, which instead of secreting oil, this gland at the sepal secretes nectar. And actually, you have two glands fused into a large single one from this sepal and one from this other sepal. You can have acute apices, a glandular margins or glandular margins, as you see here, and 8 to 10 glandular sepals, mostly Neotropical Malpighiaceae and African Malpighiaceae. For some groups, we do have glands, but they are usually nectaries. They secrete nectar instead of oil, and they are limited to a few genera, and their number is usually smaller than 8 to 10. It's usually uh, from 2 to 6. Um, the posture of those sepals can also be really different. So they can be erect, they can be only revolute at the apex, or they can be completely deflexed here, as you can see. The eliophores also vary greatly. So as I told you before, they vary in their morphology, in their position, in their shape. The only major difference here from these eliophores or nectaries in the sepals of Malpighiaceae, you will see that this one, it is pedunculate instead of being sessile, as the majority of sepal glands in Malpighiaceae. Also, the color of those sepal glands when the flower bud is mature, right before anthesis, varies a lot. So we can have light yellow, yellow, light green, green, white, pink, brown, red, and the color of those sepal glands are also correlated with the stage of pollination within Malpighiaceae. So here, for example, in this specimen, Echinacea parviflora, when we have the closed flower bud, the eliophores are white, but when the flower opens in anthesis and is pollinated, the color of the eliophore and the entire flower might change because it was pollinated, as a signal to the pollinators to understand that there's no resource there, so they can skip that flower and go to the next one with the resource. So this color changing, it's really, really important in Malpighiaceae as well, but specifically for sepal glands too. Now petals. So they vary in 3D shape, posture, and color. So they can be plain, straight, as I said before, or they can be cuculate, like bow-shaped, or sometimes when they are in the flower bud, they are keeled. So they have this costes here that they might not show it after the flowers open, or they can be really knitted and conspicuous depending on the group. So also the petals, their posture can vary a lot. Most Malpighiaceae have patent petals or deflexed here, like this one in Bersonima, and they've also greatly vary in color. Most Malpighiaceae show yellow petals, but they can also be pink, white, lilac, red, and several variations of that. Like this one in Amoremia, you can see here the flower buds, they seem to be like greenish, and they become very vivid yellow when they are open in anthesis, and after pollination they becomes like reddish or orange, and this is that mechanisms that signals to the pollinator that in this flower you will not find any resources anymore. Please go to the other one. um, Also in petals, they also vary in tuty shape and margins. So they can be obovate, orbicular, or wide elliptic. They are oftenly entire, but they can also be arose, dentate, fimbriate, or even glandular fimbriate, like with tiny glands at the end of each fimbriate. The androecian in Malpighiaceae, it's oftenly composed by 10 stamens, okay? And you have different morphologies, different variations, but each stamen, they show a very long filament, which might be usually mostly glabrous or sometimes has some kind of trichomes, some kind of pubescence. And then you have the anther itself that is composed by a very large connective, which is very, very common to bear glands, a gland at the top or a gland at the dorsal part, and also two pollen sacs, which opens as a longitudinal thing here called remose anthers instead of a pore, for example. And then you have the different variations within the number of stamens. They might vary from 6 stamens, 5 stamens, 10 stamens, 8. Actually, the number of fertile stamens, they can vary in several genera from 2 to 10, and the number of staminodes, that the number of non-fertile stamens, they might also vary from 1 to 5. So here you can see in this androecian, each stamen is fused at the base, okay, it's connate, and each yellow one is not a fertile stamen, is in fact a staminode. And they can also vary in different lengths of the filament, different shapes, and so on. And the gynoecious also has a lot of variability. So, for example, you have always 3 ovaries, 3 styles, and 3 stigmas. And the variation that we can find here is that, for example, the ovary, they are almost 100% of the times very, very pubescent. They are very, very hairy. And it's very rare to find specimens or even genera with a glabrous ovary. So that's one of the things. The other thing is regarding the styles. So they are usually straight, okay, rarely curved like this one, and they are usually found in numbers of 3. So every time you find 3 styles in Malpighiaceae, but few genera, this number might be reduced to 1 because those 3 styles are fused into a single long and thick one. Um, the posture of the styles also varies, so they can be parallel, like erect, or they can be um, uh, divergent, and they can have different types of arches. So after that, if you look at the up apex of the styles, they can have a stigma like this one, or they can have a projection. So if they have a projection here, sometimes it's called in the literature as a foliate apex, like it resembles a leaf, but it actually isn't a leaf or anything regarding the stigma. It's always the apex of the style. Here in this case, with the extension, the expansion here of this leaf projection, instead of being terminal, the stigmas, they are lateral. They are here, represented by this part, this part, this part, this part. The size of the expanded apex can also vary. And when they are not found as lateral appendices in the styles, they are terminal. And Talking lastly about fruits, we have the group of fleshy fruits, which are simple, fleshy in the hyacinth, with the endocarp hardener and concrescent with one seed forming the stone. They are mostly bird dispersed, and they are found in three different genera: Boncosia, Bursoniuma, and Malpighiaceae. They are all neotropical ones. We don't have fleshy fruits in Africa in Malpighiaceae. If you find fleshy fruits in Malpighiaceae in Africa, it might be a new genus. Please call me. So no kidding. It's really, really rare to find fleshy fruits in Malpighiaceae. So here, just for you to understand and see, you have the fleshy epicarp of the fruit, the stone, and all of those three types of fruits of genera here, they show the same morphology. We have dry fruits that are called nuts in Malpighiaceae. They are dry in the hyacinth when seeded. They are probably animal dispersed, but we don't have like any studies testing this hypothesis, so it's just a guess. So here you can see the dry, very hard epicarp and the one large seed here in the middle. And this type of fruit is only found in a single neotropical genus called Dicella. I haven't seen this type of fruit in any other type genera of Malpighiaceae so far. And you will also have the dry fruits, the schizocarps. So the schizocarps, they are compound fruits splitting into smaller units, the mericarps, which resemble a complete entire fruit unit. Okay, so here we have three different types: the smooth ones, the winged ones, and the setose, the setty ones, the bristled ones. So here in the first ones, each mericarp here, one, two, three, they split like this, and they are dispersed like this. They don't have like any kind of wings or settees, nor not any type of ornamentation, so that's why they are called smooth. And they are rare, only few genera Malpighiaceae show them. But the most common one is the winged schizocarps. So that's the same thing as I told you before, but now each mericarp might have one or several wings. So for example, here we have a dorsal wing, we have the nut, which is the region of the fruit that comprises the seed inside, and then we might have lateral winglets here at the side of the nuts. Then here is the floral receptacle, and so on. So this is a structure called areole. It's this a part of the fruit that attaches to the floral receptacle. So this is called areole. And the winged fruits in Malpighiaceae, they might show different types or numbers of wings. So here it can be like a one free dorsal wing like this one, or you can have, instead of the dorsal wing more developed, you might have the lateral wings more developed. So here you see tiny dorsal wings and huge lateral wings. So you can have one connate or bicular single lateral wing, or two free lateral wings, which is actually only this without the fusion, the connation of this part. So it makes like a butterfly shaped fruit, as it's often called in the literature, or the Y shaped fruits, which shows like three free lateral wings, which in my opinion it's only a variation of this one, that it's the X type of fruit, which has four free lateral wings. And the only difference here is that the lower lateral wings, they seem to be connate here, giving this Y-shaped for the fruit. And lastly, we have the dry fruits, the setose schizocarps. That's the same thing as I told you before, but instead of wings, we have bristles or setae here. And these are meant to be animal dispersed always, because it's attached to your skin, to your fur, to your anything, and it never gets out of it again. So now I'm going to briefly just show you some beautiful pictures of the genera of Malpighiaceae that we have in Africa, and we're good to go. So I'm gonna start talking about them and talk about the different lineages in which each of these genera are placed. So the first one is played in this lineage called Acridocarpoids in the phylogeny. So it's called Acridocarpus. It currently has 36 species occurring in most tropical Africa and in the Arabian Peninsula and also Madagascar. So it's very, very widespread in the African continent. So it's usually a tree found in forested environments, but I think more usually in dry forests and probably savannas from what I've seen from the photos that I got from them in the field. So they are they also have like flowers arranged in the tertius. Weirdly enough, they have a large nectary at the base of the sepals here. Again, it's two different glands that secrete nectar, but they are fused here. One glands belong to this sepal and the other one to this one. And it's very, very common in Acridocarpus species, and they might vary in number, in shape, in color. And from what I've seen, the max number of those glands in Acridocarpus sepals, I think it's 6, but who knows if we can find more than that because they haven't been properly taxonomically studied in Africa so far. And the flower is really, really weird. Why do I say weird? Because since we don't have oil collecting bees in Africa, and they had to adapt to new environments, their ancestor, they kind of change, not willingly, but draw time, the morphology of their flowers change to adapt to local pollinators. And instead of offer oil as the primary resource to the pollinator, these flowers are now offering pollen. So instead of having a single dorsal wing, they have now two posterior, not two, I talked about wings instead of petals. Instead of having one posterior petal, they have now two posterior petals, okay, contrasting with the only one posterior petal of the neotropical species, giving the flower a really weird zygomorphic appearance, but different from the neotropical ones. And also, instead of having remote anthers, we now have parate anthers. So the pollen is released here from the anthers through a pore instead of the entire anther. And the fruits here, they are the schizocarp, the winged schizocarp merocarp type, and they always have the dorsal wing more developed than the lateral ones. And in the wing in relation to the nut, it's always in forming like a 90-degree angle. So it's very, very different from any neotropical type of winged fruit that we find in South America, for example. It's very, very unique. So the second lineage that has African genera is the Buncosioids. So this genus is called Tristillatea. It's a genus of 21 species of lianas, usually occurring in dry forests of Eastern Africa and mostly in Madagascar. There's a lot of species endemic to Madagascar. So they also show this weird flower morphology in which instead of having only one posterior petal, you have two, and you also have parate anthers. And one thing that is really beautiful about this genus is that their flowers are really big. They are arranged in a very long tertius, and here the flower bud, every single species from what I know so far, they showed cute petals. So all the petals are cute here. They have this prominent part being like really conspicuous. The calyx, the sepals are always a glandular, and they have like very weird fruits because it's the only genus in the entire family to show more than four lateral wings. So instead of having an X type of fruit, as I showed you before, it might have from 4 to 8 or sometimes even more lateral wings, giving that starish look effect on resemblance of the fruit. And the lateral wings, they are very, very prominent. So this fruit, it's quite big from what I've seen in pictures so far. The third lineage is the tetrapteroids. We have 3 or 4 genera, if I'm not mistaken. The first one is Flabellaria. It's a liana, okay, with a single species occurring mostly in rainforests in tropical Africa. Uh, I don't actually have any photos or drawings of their flowers, but I know from taxonomic literature that they are white. uh, the abaxial side of their leaves, they have a sericeous indiment. They are really whitish and really easy to spot in the field. And their fruits they show lateral wings more developed than the dorsal one, and they are usually connate, like fused into a single structure that is orbicular. Okay, so the next one is Flabellariopsis, also again a genus with a single species, mostly occurring in rainforests. This one I had access to a beautiful drawing, but we don't actually have any field photos so far from this genus. So it's kind of similar to Flabellaria, but they were placed in different clades within the molecular phylogenetic studies, so they were considered to be different and segregated genera. So they have the only difference between them is actually that here in the fruits of Flabellariopsis, you have an orbicular lateral wing, but it's not that well developed as in Flabellaria. The remaining of characters, morphological ones, they are quite actually very similar. We have Ateropteris also. That's one of those neotropical genera of Malpighiaceae that have currently species occurring in Africa. We don't think that they were introduced there. We think that these fruits, for example, that they bear, they are water dispersed. So this species is called Heteropteris leona. It's very common within the Amazon basin, and it's dispersed in the water of Amazon's largest rivers. So we hypothesize that the water currents after the river goes into the Atlantic Ocean. The Atlantic Ocean currents actually is the responsible for dispersing their fruits and seeds here to West Africa, and that's why they are commonly found in this region. But who knows if that's true? Someone needs to test properly this hypothesis in the future. But anyway, so we only have a single species of Heteropteris. It's water dispersed and mainly occurs in rainforests. Their flowers are arranged in terses, and their fruits have a dorsal wing more developed than the lateral ones. Actually, they don't bear any lateral wings or ringlets, and the dorsal wing is kind of reduced, and they don't have any kind of glands in their sepals. Uh, the fourth group is called Malpighiaceae. The first genus that is endemic to Africa is called Calcanthus. It currently has 3 species occurring in dry forests. Those species are mostly lianas. They occur mostly here in East Africa and the Arabian Peninsula. They have really tomentose hairs induments in the ventral side of their leaves, and it's really whitish, also really easy to spot in the field. Their petals are always very, very white, very actinomorphic. They are not zygomorphic anymore as those previous genera that I showed you. The sepals, they are probably glandular, but we do see some bugs here, probably ants at the base of the sepal. So I think that they're probably looking for nectar, and if they're there, they might probably have any kind of glands there. So maybe we need to study more in depth this issue in the future. And the flowers, they are arranged in corymbs. Uh, and now we're going to talk about Digonopteris. It's a very weird genus with a single species, endemic to dry forests of South Madagascar. So they are shrubs. They have alternate leaves that kind of look like verticillate leaves, but they are not. They have white flowers. I didn't have access to any photos of their flowers, and their fruits are also represented by dry winged merycarp with orbicular lateral wings, as you can see here in this picture. And it's only found in very dry forests in South Madagascar. Madagascaria, again, the same thing as Digonopteris, but a different genus with a single species, also occurring in dry forests. Kind of similar to Digonopteris, but instead of being a shrub, it's a liana. And the weird thing about Madagascaria is that their stipules, they are connate and they are really huge. And you can see them here illustrated in this beautiful drawing. Besides that, they show flowers arranged in terces, white petals, and um, a dry winged fruit with the lateral wings being fused and orbicular, and a very, very pronounced dorsal wing, as you can see here. Also endemic to dry forests in the south of Madagascar. Microstata now, it's one of the largest genera of African lianas in Malpighiaceae. It's a genus endemic to Madagascar with currently 27 species. They occur in different type of forest environments, like from dry forest to rainforest sometimes. And I also think they occur in savannic habitats in Madagascar, but it's not that well studied for us to confirm that so far. So their flowers are arranged in corymbs. They always or most frequently have white petals. I think sometimes they might also be yellow, but again, I'm not sure because it's a very little studied genus and with few pictures of them online. And since I'm not Malagasy or even African, I never had the opportunity to do field work in Africa to confirm any of the things that I'm talking to you about now, because it's mainly coming from the literature, from iNaturalist or different sources of taxonomic literature. And they have beautiful winged fruits that show 3 lateral wings, more developed than the dorsal one, and they are always Y-shaped like that. And it's a really, really beautiful genus. I think it's the most beautiful one in Madagascar. And we also have Rhynchophora. It's a genus with only 2 species, also endemic to dry forests in the south in Madagascar. They are really similar to the other ones that are endemic to this region of dry forests in Madagascar, with white petals, with flowers arranged in corymbs. But the very weird thing about Rhynchophora is that their fruits are so unique. So if you see here, and if you learn anything with my presentation today, we would assume that this fruit would be a schizocarp and that you have three mericarps here, okay? And each mericarp has a weird wing that by the position in which is inserted in the nut, I'm not actually sure if it should be called dorsal or lateral, probably lateral. But the weirdest thing about this fruit is that um, it never actually splits. So it's an indehiscent fruit, and it looks very, very similar to a schizocarp, and it doesn't fit until now any kind of terminology that we have for fruit morphology in Malpighiaceae. So it's really, really weird. It's something that someone should really look in deep in the future, like doing anatomical study or any kind of study, because I don't know what type of fruit to actually use for Rhynchophora, because it's really, really weird and a rare, rare genus. And the last one here is Triaspis in this clade. So Triaspis comprises nowadays 15 species, occurring mainly in tropical Africa, not currently occurring in Madagascar, just continental Africa, in forested environments, probably rainforests and dry forests. So their flowers are arranged in corymbs. You can see a color change that is really conspicuous in their species. So when they're pollinated, they becomes pinkish, lilac. I don't know what color you want to call this, but they change colors to signal the pollinators. And one thing that is really, really striking and it's really different about this genus is that the margin of all their petals, they are very, very fimbriate, but not short fimbriated like the other neotropical species that I've shown you before in my presentation. Their fimbria are the longest ones I have ever seen in Malpighiaceae. They like as almost as long as the entire size of the petal. So it's really, really weird. I have never seen that in Malpighiaceae. I have no idea, no clue why they would have those kinds of fimbriae in the margin of their petals. What be the ecological function of those? But probably something related to pollination that we don't know yet, but should be properly studied in the future. Their flower buds have cute petals also in all of its species. The sepals are glandular, and their fruits are also the kind of orbicular lateral wings. So it's a dry schizocarp with each mericarp showing lateral wings more developed than dorsal ones and being conated into an orbicular wing. And the last lineage to have members occurring in Africa in Malpighiaceae, it's the stigmophyloids. The first genus is called Phylgamia. It's actually endemic to Madagascar, comprising only 4 species occurring in savannas, probably in highlands of Madagascar. And all of the species are shrubs. We have most of them having white petals, rusty induments in their inflorescences. Their flowers are usually arranged in an umbel. And the interesting thing about Phylgamia is that they bear winged mericarps that were supposed to be winged, but they are not. They are wingless. So we can see the remainings here of a dorsal wing that does not develop into anything. So that's how we distinguish Phylgamia, for example, from a very closely related genus also occurring in African Madagascar called Sphedomenocarpus, which is the last one that I'm going to talk to you about now. So Sphedomenocarpus shows 10 species nowadays, occurring mostly in savannas in tropical Africa, but most in the south of Africa and Madagascar. Most of their species show yellow petals. They are not zygomorphic. They are very, very actinomorphic. They have a glandular sepals, and their fruits have only one dorsal wing developed. So it's really interesting to note that it shows like a huge dorsal wing when their sister group, which is Philgamia, does not show anymore any kind of dorsal wing here. And the last one is Stigmophyllum, which is a mainly neotropical genus, but we currently have one species naturally occurring in Africa, in West Africa. It's the same case of Heteropteris. It's a species that is really common in the Amazon basin. Their fruits here have reduced dorsal wing, and they have chambers of air here that probably floats. So that's why they are dispersed from the Americas to Africa, probably by ocean currents. And their flowers are arranged in umbels. They always have yellow petals. The most striking different thing in Stigmophyllum is that the apex of their styles here in the genuation is expanded. So they might be expanded like this or into a leafy-like structure. They always bear eliophores, oil-secreting glands on their sepals, and they always occur in rainforests or sandy beaches or different types of environments related to rainforests. And that's it. That's what I had to talk to you about today. I'm sorry for the long presentation, but that's it. Most of it was based on this book, Morphology of Malpighiaceae from Brazil, that I published last year. It's also free to download on ResearchGate. You have the link here, and I just wanted to say thank you to all my funders, both from Q and from Brazil, because this is based on more than 10 years of research. And that's it. Thank you for having me.
Thank you very much.
Thank
Let
you
me
very much.
just stop sharing. Yay.
Thanks a lot.
Sorry for the long presentation.
No, we are happy